Alrighty, this is Trig Lecture 120 and 121. It's a review. Given a figure, the student will use inverse trig functions to find the measure of an indicated angle, and we're going to round to the nearest degree because that's what it says to do. Round it to the nearest degree. Here we go. And again, we're going to be using a figure, that's a drawing, and we're going to find the measure of the indicated angle. There's a little question mark there. I usually draw thetas, but I noticed on the worksheet that it had question marks instead of thetas, so I put question marks there. When I go to figure it, I'll just write theta. Here we go. Let's see if I can move this. Haha, I can. Here's the angle I'm looking for. I'm going to call it theta. I want to know the measure of this angle, and it says to use inverse trig functions. Inverse trig functions, and we're going to round to the nearest degree. So I'm going to tell myself, well, looking at this, I could say that the tangent of theta is 5 over 21. The reason I would choose tangent is because I look at this triangle, and from this perspective, the angle that was indicated, I've got the opposite side and the adjacent side. And the tangent, the definition of tangent, is opposite over adjacent. So I'm going to use tangent. And then I'm going to think, well, if tangent of theta is 5 over 21, then theta is the inverse tangent of 5 over 21. And then we just evaluate that with our calculator, indicate that we're going to do an approximation, and we're going to round to the nearest degree because that's what we're asked to do. So we're going to take our calculator and find inverse tangent of 5 over 21 equals, I've got about 13 degrees. 13.39 or 30. So it said round to the nearest degree, so here we are. That's simple. I determined that I was going to use the tangent function because of the sides that I was given. I made that statement, and I said if that's true, then this has to be true. Take the inverse tangent of both sides, so to speak, and then I evaluated it using my calculator. And I've got a key around here somewhere, see if I made a mistake, which I do sometimes. But I didn't that time. Yay, I got it right. Okay, let's take a look at this one. Get rid of my little... I'm looking at this angle this time. I'm going to call it theta just because I like to call it theta. But on your worksheet it'll say question marks. And I'm going to say, which function am I going to use? That looks like tangent again. The hypotenuse is unknown, so once again I'm going to use tangent. 1 over 3, the opposite over the adjacent. And if tangent of theta is equal to 1 over 3, then theta is equal to the inverse tangent of 1 over 3. And we can evaluate that with our calculator. If I can find it, there it is. And then round it to the nearest degree because that's what it said to do in our instructions. Always pay attention to what the instructions say. That's something I forget to do sometimes, but I'm paying attention today, by golly. I get about 18 degrees. Okay, let's take a look and see if we got that one right. Yay! Pretty simple, straightforward stuff. Just a little walk down memory lane here. Got another one. That's a triangle. I'm looking for this angle right here. I'm going to call it theta just because I like to. That's my indicated angle. That's what this means up here. Given a figure, the student will use the inverse trig function to find the measure of an indicated angle, that's the one with the question mark, to the nearest degree. So it's indicated by a question mark. Now which trig function am I going to use? Well, I'm given the opposite and the hypotenuse, so I'm going to use the sine function this time. I'm going to say, well, the sine of theta is equal to 10 over 18 by the definition of the sine ratio. So if this is true, then theta has got to be the inverse sine of 10 over 18. We could reduce that, but the calculator doesn't care whether that's reduced or not, so I'm not going to bother. 10 over 18. Take the inverse sine of 10 over 18. And I get about 34 degrees. 33.7, and it said round it to the nearest degree. So I'm going to round it to 34, and then hope that I haven't made a mistake. And we'll check and have a look. Yay, 34. And there we go. Got one more to go, and I'm sure by now you already know exactly what to do, but you're sitting there yawning, but I'll go ahead and do one more. Here's our indicated angle. I'm going to call it theta, just because I like to. And what sides am I given? I'm given the hypotenuse and the opposite. So once again, I'm going to use the sine function. If I was given the adjacent in this side, I'd use the cosine function. And I would use either sine, cosine, or tangent functions, just because those are the three that I have on my calculator. Makes it a little easier. Here we go. The sine, because of the sides that I'm given, of theta is opposite over hypotenuse, which is 10 over 21. I don't want the sine of theta, I want theta, so I'm going to say, well, if this is true, then theta has to be the inverse sine of 10 over 21. And we do that with our calculator. Let the calculator do the walking. Oops. Left off my inverse sine. Yeah, I did it that time. Okay, so I got the inverse sine, 10 divided by 21, equals about 28. Degrees. There we go. That's what we're doing. Let's see if I got it right. 28, yay! So that's how you do it. If it says, given a figure, use the inverse trigonometric function to find the measure of the indicated angle to the nearest degree. That's what you do. Very simple, straightforward stuff. You can do this.